Hello aspirants. So today in this video, we'll try to understand one of the most significant development with respect to science and technology in India. So yes, we are going to look at LIGO India. So what is this project? So recently, government gave an approval to set up this LIGO detector in Maharashtra in Hingoli district at a cost of around rupees 2600 crores. So what is this LIGO detector? What does it detect? What is gravitational wave? What is this concept of gravitational wave? Is this the only one gravitational wave observatory, or are there other gravitational wave observatories also across the globe? So we'll try to develop a holistic understanding of this, and we'll see how it can benefit India or in large the society itself. Hi, I am Jwala Kumar and I am faculty of science and technology. So this LIGO caught the attention. Why? Because it was in news. So government gave an approval, and it was in news again in 2015. In 2015, for the first time, this LIGO detector had detected the merger of two black holes which had happened some 1.3 billion years ago. And for that, in 2017, the researchers received the Nobel Prize. Because of that, it is said that this observatory is very significant for the scientific community at large. So we will try to understand why we are setting up this LIGO laboratory or LIGO observatory in India. But in order to understand LIGO, we need to understand gravitational waves. It is this gravitational wave that this LIGO will detect. So in order to understand gravitational waves, we need to have an understanding of the concept of space-time given by Einstein. So Einstein, way back 100 years back, gave this theory of, more than 100 years back, gave this theory of relativity. He gave two theories of relativity. The first one is called as special theory of relativity, and the second one is called as general theory of relativity. In his special theory of relativity, he talks about space-time. So let us just try to understand this concept of space-time. So Einstein says that space and time are interlinked. Why are we hyphenating space and time? We are hyphenating here because Einstein said that space and time are interlinked. Time is a relative concept. So if you consider time, what is time? Time, if you consider it as ticking of clock, then that clock will not tick at the same speed on Earth and on Moon. On Earth, it will tick faster. On Earth, it will tick slower than compared to Moon. If you go near a black hole, that ticking clock will literally stop. So what we are saying, that time depends on the space where you are measuring it. So time, when we talk about time, we say that 13.8 billion years ago, Big Bang happened. So that 13.8 billion years ago is the origin of time itself. Was there no time before that? So this says that space and time are interlinked. So this concept of interlinkage between space and time was given by Einstein in his special theory of relativity in 1905. In next 10 years, in another 10 years, Einstein came up with a general theory of relativity. So he goes ahead and elaborates more with respect to space-time. So he says that this space-time, matter interacts with space-time. Matter interacts with space-time and it warps the space-time. Now this might sound confusing, so let us just try to understand that what is this space-time, how can we visualize it, and when Einstein says that it interacts with matter, how can we visualize it? So let us imagine that this space-time is nothing but a big piece of cloth. So you imagine that if you are sitting in your room, you imagine that there is a big piece of cloth running over your head, and it is quite tight and has been tied from the four ends. Now imagine that this cloth is nothing but your space-time matrix. What Einstein says in his general theory of relativity, that if you imagine that you have a big metal ball, and if you place a big metal ball on that sheet of cloth, then what will happen? The cloth will bulge down. So this is what he meant by saying that matter interacts with space-time. So in this diagram, so you can see that if you consider this as your space-time matrix, so what we have done, we have placed a metal ball. So imagine this is a metal ball. What is this metal ball doing to the space-time matrix? It is warping, or it is bending the space-time itself. If you place a heavier metal ball, it will warp the space-time matrix more. If you place a black hole, so it will bend it more. So that is the uniqueness about space-time. It interacts with matter. Matter bends the space-time matrix. So Einstein, in his general theory of relativity, gives a concept of gravity which is fundamentally different from what is given by Newton. What did Newton say about gravity? Newton said that if you take two masses, and if they are separated by a distance of r, then what is happening, that these two masses are attracting each other. So gravity, according to Newton, is force of attraction. But Einstein differs. Einstein says that matters are getting attracted not because of force of attraction, but because of the curvature of the space-time matrix itself. How do we understand this? So in order to understand this, let us imagine that there is a metal ball here. You have placed a metal ball here. When you place a metal ball here, what will happen? This smaller metal ball will get attracted, so it will move closer to this big metal ball. Why is this moving towards this? And Newton will say that it is the force of attraction between these two balls that is making the smaller ball come closer towards this. But Einstein will say that it is the curvature of the space-time matrix itself that is making the balls come closer to each other. This is the Einstein's conception of gravity. So he is saying that matters are getting attracted towards each other because of the curvature of the space-time matrix itself. This metal ball feels the curvature and gets closer to this large metal ball. So it is Einstein's conception of gravity. So what we are saying here, that this space-time matrix, it interacts with matter. Now if you imagine that this ball is not there and just this ball is present here. If we kick out this ball, with this ball with another big metal ball, what will happen to the cloth? So it will produce ripples in the cloth. So ripples, just like if you have seen in case of pond. So if you are sitting near a pond and if you throw a stone, so when you throw a stone, it creates ripples on the surface of pond. Similarly, in this space-time matrix, if you kick this ball out, what will you do? You will be creating these ripples in space-time matrix. These waves or these ripples in the space-time matrix is what is called as gravitational wave. This concept of gravitational wave was given by Einstein in his general theory of relativity only. It was given in 1916, but we have been able to detect it only in 2015. So it has taken scientists more than 100 years to discover this. But whatever theories Einstein have given, so scientists and slowly are able to prove that most of his theories are coming out to be true. So this gravitational wave, in normal scenarios also, when matter moves in space-time matrix, they produce waves. So they produce ripples in space-time matrix, but these waves, these ripples in the space-time matrix are they are not detectable. If they travel, they are not detectable. So one of the unique features again of this gravitational wave is that these gravitational waves travel at the speed of light. So they will travel at the speed of light, and these gravitational waves, some of these gravitational waves can even reach Earth. But in normal scenarios, when these gravitational waves are very feeble, so it might not reach Earth. So it might get lost, or we might not be able to detect it. But it was believed that if in some cataclysmic events such as when two black holes they merge, or when two neutron stars they merge. Remember, black holes are, what are black holes? Black holes, they have infinite density. because they are having infinite density, they warp this space-time matrix to a very, very large extent. So when two black holes, they are moving towards each other, so when they collide, they produce intense gravitational waves. Now these intense gravitational waves will travel through space-time and can reach Earth. So what happened in 2015 was that some two black holes had merged 1.3 billion years ago, but the gravitational waves produced then reached Earth now. So it has taken more than 1.3 billion years to reach Earth. Imagine, in fact, humans would have not existed also when this merger would have taken place, but now we are able to detect it. So how do we detect these gravitational waves? How do we detect these ripples in space-time matrix? So that is what we will try to understand. So in order to understand how do we detect it, we must understand one of the property of the gravitational wave is that because when it moves through the space-time matrix, it has a property that it stretches matter in one direction and it compresses matter in another direction. So we'll see that we utilize this property. So just remember that gravitational waves have the property that it will stretch matter in one direction, and in another direction or perpendicular direction it will elongate the matter. So we utilize this principle, and we utilize one principle of light, that is interference. So we utilize laser interferometer to detect gravitational waves. So the earliest gravitational wave observatories was set up in USA. So in USA there are two gravitational wave observatory, one in Washington and other in Louisiana. So they are 3000 kilometers apart. So what is the working mechanism? What is the working apparatus? The working apparatus is that they have two arms. So here you can see there are two arms. So here you can see there are two arms. These two arms are vacuum made. They are tube like structures. They run at 90 degree. So imagine that you have So what are we doing here is that we are creating two arms. These two arms are of equal length and they are at 90 degrees. So what is the objective here is that we will pass laser light in these two arms. So these are your mirrors. These are your mirrors. And we throw a laser light and we have a beam splitter. So we have a beam splitter. This beam splitter, what it does, that it splits this laser. This is a laser. So it will split the laser and it will send the beams in the two arms. So one of the laser beams will move in this arm and the other one will move in this arm. It will get reflected back from this mirror. It will reach this point here. So let us say that this point is O, and this laser will reflect back from here and it will reach again at point O. So this design is using the principle of laser interferometer. What is interference? Interference means when light from different sources they combine, they produce interference, and we are trying to study the pattern of this interference. Through this we can know whether gravitational waves have passed or not. So let us just try to understand how it works. So these arms that are built in USA, they are of 4 kilometers long. So they are 4 kilometers long and they are vacuums. They are vacuums, and what we are doing, we are throwing a laser light, and this laser light is splitted into two parts. One will move in this arm, the other one will move in this arm. Now both the lights will be reflected back and they will reach at this point. Since the length of the two arms are same, and since we are using the same laser light, it means the speed of the laser is same in both the arms. If the length is same, if the speed is same, so the time taken to come back at this point is 0, or the time difference at point O is 0. It means the lasers will take the same time to move in both the arms. So we keep recording the time here. So we keep recording the time here, and most of the time we see that the time difference recorded is 0. Most of the time we see that the time difference recorded is 0. Now imagine that gravitational waves are going to hit this one. So let us imagine that two black holes are merging. So these are two black holes and they start producing gravitational waves. So these gravitational waves are traveling, they are traveling and they hit this apparatus. So these are your black holes which are merging, and these are your gravitational waves. So these gravitational waves are ripples in the space-time matrix. So this merger happened billions of years ago, but the waves are now able to reach the detector now. So what will happen when these gravitational waves will hit this apparatus? So what it does, it stretches the matter in one direction, elongates the matter in another direction. So now you imagine that, let us say it compresses this arm, and it elongates this arm. So it will compress this arm, it will elongate this arm. So now the length of the tubes or these arms have changed very minutely, but it will be changed. So what will happen now? Now the time difference here recorded will not be 0, it will be some time value. So there is some time difference recorded. So this tells us that the gravitational waves have hit the apparatus. So this is the principle that we are using to detect the gravitational waves. So this detector is in USA. Now why are we trying to build more such type of detectors? So in order to know the source, in order to know from where these gravitational waves are coming, we need we need many such ground-based observatories. In fact, we have also sent a space-based antenna also, and in future we will be sending some more. So European Space Agency will be sending some other space-based laser interferometer antenna also. So we need a combination of these observatories to get a better picture, to get a clearer picture from where are we getting these gravitational waves. So we have two in USA, we have one more observatory in Italy. So one LIGO detector, two twin facilities, one in Washington and one in Louisiana in the US, and the third detector, that is Virgo, is in Italy. So Virgo in Italy is again similar only, it is ground based only, but the length of the arms is less. And the fourth one known as the Kagra in Japan. So this is the Kamioka gravitational wave detector. So let us just see this this Virgo and Kagra. So this is the Virgo neutrino detector, Virgo detector. So this Virgo detector, it works in tandem with LIGO only, LIGO of USA. So they both were involved in detecting the observation in 2015 when the two black holes, merge of the two black holes were detected. So here you can see again they both are at 90 degrees, both the arms are at 90 degrees, but the length of the arms are a little shorter. So the length of the arms are 3 km, but the principle is still same. We are using laser interferometer. We are looking at the interference of the laser and we are trying to gauge that what has happened. So this is in Italy. Then another one that is in Japan. So Virgo, some basic facts are given that Virgo detector started in 1996 and it was completed in 2003, and it has 3 km long arms, mirrors and instrumentation inside are in ultra high vacuum. So this we have said that these arms are in vacuum, and they LIGO and Virgo both are working in tandem or both are collaborating since 2007. The another detector is this one, Kamioka gravitational wave detector. Kamioka gravitational wave detector, that is also in short called as Kagra. So in this diagram you could see that this Kagra is underground. So in underground, this is the underground gravitational wave observatory, and it is placed 200 meters below, and the length of the arms here, is again 3 kilometers, but it is at 90 degree only. It is a underground detector. This Kamioka, so if you are aware, this Kamioka is also the place where we are detecting neutrinos. The largest neutrino detector, that is the planned largest neutrino detector, will also be placed in these caves only. So it is a very significant observatory. So this is at present the only observatory, gravitational wave observatory in Asia. So its work started way back, but it has started operation recently from 2020. So Kagra, it is Asia's first gravitational wave observatory, and it is the first in the world which is built underground. So this is the world's first underground detector, the first whose detector uses cryogenic mirrors. So what do you mean by cryogenic? Cryogenic, whenever you hear this term, cryogenic means that when the temperature is much below than -150, or the cutoff is the temperature should be lower than -150 degrees Celsius. So at this stage we have the cryo stage. So it increases the efficiency of the mirrors, that is why we are keeping it at cryo state. Now, let us look at the LIGO that India will build. So this project will be called as LIGO India. So the feature is that, yes, it will also be 4 kilometer long. So it will have 2 arms, just like in the USA. So we will have 2 arms which are at 90 degrees, and each will be 4 kilometer long, and it will be vacuum tubes only. It is being built by combination of DAE and DST. DAE is Department of Atomic Energy and Department of Science and Technology. They both will work together, and they will help in development of this project. It will be set up in Hingoli district of Maharashtra. So this district is around 450 kilometer east of Mumbai. So the first run, the scientific run, will be completed by 2030. So we expect that these instruments will be set up by before 2030, and the scientific run will begin. So you must take a note that India is not making the instruments. India will assemble the instruments. USA and the other detectors, these agencies will provide the instruments, and we will assemble those instruments in India. So what will be the benefit of having LIGO in India? So first of all, yes, there will be scientific benefit. Just like LIGO in USA, it generated the interest among the students, among the scientific communities, among the educators. Similarly, it is expected that LIGO India will also generate great interest among the scientific community, whether they are students, whether they are scientists, or whether they are just educators. So that is one of the objective, that is one of the benefit. And also it will open other areas of astronomy also. So we will develop more deeper or better understanding of our universe, or the origin of universe itself. And for a country like India, we need to come up with such type of projects. Why? Because when these type of projects come, they bring development to the areas. So it can bring development to this part of Maharashtra, and it will create job opportunities also there. And mind that these jobs that will be created, they will be highly skilled jobs. So when we create such type of setups, they create high skilled jobs, which is required for any country, which is required for any developing country to become developed. The other benefits is that it will unleash new avenues for scientific talent that we have seen. It will inspire the next generation. Yes, so one of the other benefits is that it can inspire the next generation. So nowadays we are seeing that women are not entering into STEM field, that is science, technology, engineering and mathematics field. But if these instruments or these setups come up, so it will generate interest among even women also, even among the youth also. See, for a country to get developed, we also need that the best minds of the country, that is the best brains of the country, should not drain away. Rather, we should have the facilities so that we are able to keep them, and we are able to get their services. Until unless the best brains of the country are serving India, we will not see the development of India, or it will take more time. So such type of projects are needed for overall development of India itself, and we have seen that it can create jobs. So it will benefit in a holistic manner. It is not just a scientific pursuit, but it will lead to development also, and it will inspire the youth also. That is the advantage. So since we have seen these ground based detectors, so Europe or European Space Agency, they have also ventured into setting up of space based antenna. So what is this LISA? LISA is a space based your laser interferometer space antenna. So here this LISA Pathfinder was sent by ESA, it was sent to Lagrange point L1. What is Lagrange point L1? So if you take this as sun and this as earth, so it is a point between sun and earth. It is a point between sun and earth. What is the significance of placing something at L1? It gets anchored with respect to earth. If you place something closer to sun than earth, then it should have moved faster. It should have moved faster than earth. It should have completed one revolution in less than 365 days. But here you will see that it also completes the one revolution in 365 days. So it is getting anchored with respect to earth. So the gravitational wave, the gravity from sun and earth, they act in such a manner, or they combine in such a manner that any spacecraft that you place at L1, it remains there, and we need to spend less fuel to remain there. So this gravitational wave observatory was sent. So it was a experimental one. So we have sent and we have tested the critical components, and European Space Agency have tested this, and they are coming up with a further plan that they will be sending further projects. So the further project that will be sent with respect to detecting gravitational waves from space is called as Evolved LISA. So this LISA was sent by ESA, it was sent to L1. So this mission ended in 2017. LISA Pathfinder is paving the way for future missions. So the future mission that they are planning is this one. This is called as the Evolved LISA. So what they will be doing in Evolved LISA, so they will be sending 3 spacecrafts. So in this diagram you can see that there is this one spacecraft, there is this another spacecraft, and there is this third spacecraft. So these 3 spacecrafts will form a triangular pattern, and the distance between them will be around 1 million kilometers. The distance will be around 1 million kilometers, and they will again follow the same principle of laser interferometer only here, but the pattern is triangular, and they will be in space. And here you can see that in this picture we are trying to show that there is this merger of 2 giant black holes, and because of that merger you can see there are waves produced in the space-time matrix, and when these waves hit this apparatus, so the distances between the arms will change, and that is how we will be able to detect the gravitational wave. So this LISA, this Evolved LISA is a future project, but this also you should take a note that this will come in news in future. So you should take a note. In fact, UPSC has asked questions on this also. Let us just try, we'll look at the questions also, but let us just try to understand that what is the benefit of studying gravitational wave? Why is there so much pursuit with respect to understanding gravitational waves? So we have always been perplexed by the question that how this universe has come into existence. So if we understand black holes, so it is said that Big Bang, your universe came into existence because of Big Bang. Some scientists ask what was before Big Bang. Some of the scientists like Einstein said that so Big Bang has occurred because before Big Bang there was singularity. What is singularity then? Singularity is nothing but the center of a black hole. So the universe has come into existence because there has been an explosion in the center of the black hole. So if black hole is the source of the universe, now if we can detect the gravitational waves, if we can know that black holes are merging, then we can have a better understanding of how this universe has come into existence. So there are theories which says that there is not only this universe, but there are many universes, because many of the black holes might be exploding and they might be creating what is known as multiverse. So the part of the universe where we are living is universe, but there are multiple universes. So this is one of the theory. So we will be able to corroborate such type of theories if we can detect, or if we can detect gravitational waves. So we need that, or we need these detectors. Also it will help in understanding the existence of neutron stars. See, how are neutron stars formed? Neutron stars are formed from a very high mass star. When they die, when the fuel finishes, so every proton and electron, they combine or fuse to form a neutron. Neutrons are also they also have very high gravity, but they have gravity lesser than a black hole. So, we will be able to understand very high mass objects in this universe like black holes, neutron stars, and we will be able to know the origin of the universe itself. So, that is the idea of why we should be having gravitational waves. So, let us look at some of the questions which UPSC has already asked based on this concept. So, let us just try to read this question. So, this question says that scientists recently observed the merger of giant black holes billions of light years away from the Earth. What is the significance of this observation? So, UPSC is asking very basic question. So, we need to have some understanding with respect to gravitational waves. So, what is the answer to this question? Higgs boson particles were detected. So, this is not the correct answer. Higgs boson particles, they were detected in CERN laboratory in 2012. So, for that detection in 2013, Nobel Prize was given to Peter Higgs and Francois Englert. So, this CERN laboratory, it detects the subatomic particles. Gravitational waves were detected. Yes, so this is the correct answer. Possibility of intergalactic space travel through wormhole was confirmed. So, what is this idea of wormhole? So, wormhole, again we will have to go back to the theory of relativity. Einstein, in his general theory of relativity, says that the space-time matrix could be curved in such a way that there are some bridges created between this space-time, that we can do a shortcut travel or short travel. So, we can eventually do, or we can do time travel in theory. So, this part of Einstein's general theory of relativity has not been experimentally proven, but Einstein talks about wormhole. So, he says that there are some bridges, these bridges are what are called as wormhole. So, this merger of black hole is not related with wormhole. It enabled the scientists to understand singularity. What is singularity? For singularity, we just need to understand singularity is nothing but a center of the black hole. So, it is giving a more picture about the gravitational waves. So, when two black holes they merge, so they produce gravitational waves, intense gravitational waves. So, this is what we are trying to detect through the detector. So, this is not related to this. So, this part that it enabled the scientists to understand singularity is not related with this part. So, the correct answer in this case is your B, gravitational waves were detected. Now, let us look at another question. So, what is the purpose of Evolved Laser Interferometer Space Antenna ELISA project? So, you should take a note whenever you see this term interferometer, whenever you see this term in the previous question also or in other questions also, whenever you see this term laser interferometer we are utilizing it to detect gravitational waves. So, in LIGO it is laser interferometer gravitational wave observatory, in LISA it is laser interferometer space antenna, here in Evolved LISA also we have this laser interferometer. So, space antenna project to detect neutrinos. So, it is not about detecting neutrinos. For neutrino detection we have other types of observatories to detect gravitational waves. Yes, this is true. So, let us eliminate these options also. To detect the effectiveness of missile defense system. So, it is not related to missile defense system. To study the effect of solar flares on our communication system. So, solar flares was also in use, but it is not used for detection of solar flares. So, the correct answer here is gravitational waves. So, I hope with this small video the concept of LIGO would be clear to you, the concept of gravitational waves would be clear to you, the idea of space time, that time is a relative concept, that would also be clear to you. Hope to see you in other such videos. Thank you.